Dear students, in this session we are going to study about how to draw a NOR logic for a given expression. So let us see one given expression here. Before going to see this one, we'll try to see the basic thing. That is, this is a NOR gate. So if you give A and B as an input to a NOR gate, you'll get A plus B whole bar as an output, which is equal to an AND gate. At the input side, bubbles are there. This is equivalent to an OR gate. So OR gate output side bubble is equal to AND gate bubbles at the input side. I mean bubbles at the input side of an AND gate. So this is the basic thing for drawing the NOR logic. Now, for example, here there is an expression given y is equal to a bar b plus c bar. How to draw this one? A bar b is given to one AND gate. So here you will get a bar b. Now here c bar directly I have taken. So when you are giving, usually when you give c to a NOT gate, you will get c bar. Okay. Now to this OR gate, if you are giving inputs, so a bar b plus c bar is an output. So we got this output y at this gate. Now here, how to convert this to NOR gate? Now let us see. So at the input side, when you want to, so let us draw this figure once again. So this is AND gate. Okay. So this is C, and here this is an OR gate. Okay. So at the input side of an AND gate, if you draw a complements, then it should write another double complement to nullify or not to disturb the function. So if at all a bar is there here at the input side, you draw for a bar complement becomes, again it becomes A. For B, if you apply complement, it becomes B bar. Okay. So A bar whole bar becomes A and B becomes here B bar. Now here, the output side, at the input side of, if you want to draw a bubble at the input side of OR gate, then you have to draw, here there is no requirement for this. So let us try. This is C. So in this expression, I mean C bar is given. So here, this C bar, as usually I'm taking. Now, this expression when I'm using here, I'm using a bubble at the output side to convert into NOR gate. But when I'm using a bubble, again I have to use another NOT gate for using double complement not to disturb the, in order to not to disturb the function. So here this is A, B bar, C bar is given to this AND gate. Now let us redraw this figure. So here bubbles at the input side of OR gate can be drawn as A NOR gate. This is A and this is B bar, and here C bar, if you are writing C, then use a NOT gate like this and give it to another NOR gate. When you are using a bubble at the output side, use double complement so that it will not disturb the function. So this is the logic diagram using NOR gates only. So let us go for the next circuitry to draw and have more practice on this topic. Okay. So this is another expression. We'll try to solve this one. We learned that the bubbles at the input side of the AND gate is equal to a NOR gate. Okay. So here, try to apply bubbles at the input side. So there is a function f is equal to ab bar plus cd bar e plus bc into a plus b. So this has been drawn. Let us apply here quickly bubble at the input side. So if you are applying bubbles at the input side, for this bubble you have to apply complement to this. Double complement will not disturb the function. 0 here, I mean I have a complement here. So b bar is there. Apply one more complement here, it becomes b. So next one, here apply bubble. or complement. So this should become C bar and a double complement. Okay. Next here, apply, and here you'll get B bar, and here C bar, and here this is A bar, and this is, okay, this is a NOR gate, no? So no need for drawing for NOR gate, okay? Okay, we'll leave it of this. Only for AND gates we can apply here. Now let us go for the next step. Now, coming to this one, if I want to apply a bubble at the output side of the OR gate, then I have to use one more NOT gate at this place, or it is, okay? And next one, if I'm applying at the input side of a bubble at this place, then for this complement, you have to apply complement at this place. And for this complement, you have to use another NOT gate at this place. So let me redraw this one. So if I am trying to draw a complement at this place, for not to disturb the function again, one more NOT gate I have to use. NOT gate I have to use for nullifying the a single complement. Okay, so when you use double complement, it will give the original function. So let's redraw this function. Okay, so here this is wait for a moment, we will try to I will try to draw. So here, so bubbles at the input side, okay, this is converted to A bar, and this is converted to B, and this is converted to now an OR gate. And next one is C bar D, because double complement, C bar D is given to another NOR gate. Okay, next these two are given to another NOR gate. These two are given to another NOT gate. This NOT gate is given to here. Okay, next one is B bar, C bar, next one A bar, B, they both are applied to a NOT gate. Okay, so here I'm using a NOT gate here. So this is given to a NOT gate here, and then I'm using double complement. So that's how this expression can be turned out into a logic circuit realizing only using NOR gates. Okay, so we'll go for the one more example for learning and have more practice on the NOR logic. Okay, so this is another circuitry. So where F is equal to CD, B plus C into A plus, let me erase this. Okay, so plus B C bar plus D E bar. So this is in the brackets. Okay, so here, what we have done is CD is given to one AND gate, B plus C is given to OR gate, A is given directly. So all these three terminals are given to AND gate to get an output. So this is BC bar. So BC bar is given to AND gate, DE bar. So here it is given to AND gate, and you are given to OR gate, you get the sum of this one. So this complete expression you are getting at this point, and this one you are getting at this point. So these together are being ORed by using this one. Okay, so I will try to convert this into NOR logic. So we learned that when we apply at the input side of this AND gate, it will be converted into NOR logic. But when you are using a complement at that point, you have to give another complement to nullify or to balance the function. Okay, so this is C bar and it is D bar. Next, this is already NOR gate. So here, It's an OR gate. So here at the input side, if you apply a complement, you apply at the input output side of the OR gate. So it is turned out to an OR gate. Now, if you use one of the input as a complement, use another NOT gate like this by using a NOR gate. Okay. Next one, if I'm using bubble at this place, just give a complement at this place. Next one, apply complements B bar, and this is turned out into C bar, double bar is C. Next one, this is D bar and this becomes E, not E bar. Okay. So complements applied at this point. Now, if I want to turn this OR gate to NOR gate, use two NOT gates like this, one complement and another complement. Will not disturb the function. Again, you will, if you use want to turn this OR gate to NOR gate, then use double complement and then you will get the output function. So let's redraw this function as C bar, D bar. They both are given to an OR gate. Okay. And again, they are given to another NOR gate as a NOT gate. Okay. And here B and C, they are given to an OR gate. Okay. And A bar is given to, these three are all given to an OR gate. Okay. So here again B bar C is given to an OR gate. Next D bar E bar is given to an OR gate. These two NOR gates are given to another NOR gate. And these two are given to another NOR gate. Observing these two. Okay. The output of this is given to final NOR gate. Okay. So this is the final logic diagram for drawing, redrawing this. A basic logic circuit is changed to NOR logic. Okay. So entire circuitry is drawn by using only NOR gates. Thank you, students.